recently formed, Office of the Chief Technologist, and his title has the statement "Game-Changing Technologies." Now, I can't think of anything more appropriate to have in your title when you're at a NewSpace conference. So with that, I'll let Preston talk about himself and everybody on the panel. So, Preston.
Thanks, Gary.
Welcome.
Good afternoon. I hope we all have had a cookie and we're ready to talk about low-cost, reliable access to space. So my name is Preston Carter, as you said. I'm actually just joined NASA. I have, when I had hair, I was part of NASA in the early shuttle program. And since then, I've gone off to Livermore Labs within the Department of Energy. I've been a program manager at DARPA. I've started my own business on advanced propulsion and power. And now I've returned to NASA in order to help them form the Game-Changing Technologies division within the Chief Technologist of NASA. So just so you know, is that the idea of Game-Changing Technology division is to have a DARPA-like organization within NASA to try and bring innovation and more agile and adaptive ways of promoting and encouraging and enabling advanced technology and innovations. So that's my job, and then so I'm very interested. My job is mostly listening. My job is to identify problems, often expressed as concepts. Concepts are more solutions. I'm more interested in what the problems we are and whether what are the solutions to those problems once identified. But people express things a lot of different ways, and that's just a part of my job to identify those problems and seek solutions. Now, today we're talking about low-cost access to space, and I wanted to start with a story. I've delved on this problem off and on for about 30 years, and it's a difficult problem. It's very complex, and everyone has many different views, and that's appropriate because this low-cost access to space is difficult from the demand side, from the business side, from the technical side. Is very challenging, and our ability to solve that has. Do you think we have achieved low-cost access to space today? I would say no. And have we tried to do different ideas to try and achieve low-cost access to space? I think we definitely have tried. Have we failed? Yeah, I think some would agree that we have failed in some cases. So it's a knotty problem, and it's something that I think we have to keep addressing. In this panel, I think, and questions from the audience will be interesting in this discussion. Let me share my story. There's a young man out there, Simon Sorensen. Simon, are you in the room? No, he's still having a cookie. So he's a young man right out of high school. He's a freshman in engineering going to San Jose University. He's all excited to become an aerospace engineer. And we were talking previously about that. And so, here's a story that's I think, to understand the difficult problem. About 8 years ago, I was in the Pentagon talking to a decision maker, and the topic we're talking about is the technology development related to low-cost access to space. And the position this decision maker had was startling to me and quite different from my view of the world. His opinion was that low-cost access to space was impossible and not achievable, and that we should only be concentrating on exactly the way we're getting to space today. And that was, in his opinion, the end of discussion. Now, I point this out because I doubt very few people in this audience share that opinion. But it's very interesting to understand that there are many people in this equation, and some people have that opinion. Maybe it's because of their frustration in seeing the trying and the failing. Maybe they don't have the convictions that I think we share in this room that this is an achievable thing. But also, they could be right as well. Maybe it is impossible. I don't share that, but we have to understand that there's a lot of people who are in this discussion that not necessarily are enthusiastic. So I wanted to share that. So we have a complex problem in solving and achieving low-cost, reliable access to space. Really, there are the way I look at things, there are two sides of the problem. There's the demand side. That's the market size, the customers. A lot of the solution for low-cost space could just be economy of scale. We get a lot of launches, the prices automatically come down because of volume, economy of scale, the learning curve, things like that will drive it down. We know that, it's well understood. There's a catch-22 there, is if it's too expensive, we can't get a lot of market, we can't get a lot of customers, so how are we going to get the cost down? So there's a chicken and egg problem there, and but there is definitely a demand side of the equation. Many people have opinions on how to up the number of launches by the size of payload, the nature of the payload, let's say fuel depoting and other things. There's many strategies there, and those are definitely on the demand side. There's also the business and technical side of things. Engineers will tend to talk about performance of the vehicles, reusability, lightweightness, modularity, things like that in order to achieve performance. Business guys may look more towards the cost, how to get lower cost and other things in order to make the margins for selling low-cost access space more attractive to investors. There's also partnerships, partnering with different people that can bring different value to the formulation of the solution. And these are all very important aspects of low-cost access to space. So when they asked me to be the moderator for this panel, I looked at our panel, and at first I said, these guys are completely unconnected to each other. I go, man, look at this motley crew. How can these people be a good panel? But there was a lot of wisdom put together in this panel. There's a lot of diversity. For example, representing the market, we have Al Tadris from L'Oreal. He may have some things to say and represent adequately the market. We have Charles Miller, who I think most of you know. He's looked at this and looked at the market side of things for a great deal of time. We have the business and partnership aspects, people who kind of understand how that can play in low-cost access space. So from KSC, we have Jim Ball, who's very active in the ground facilities and how that can play in low-cost access space. We have Jess Sponable, who is here for AFRL, who's has studied this problem for a great deal of time and knows how business and government can play in achieving this. We also have from Space Access Society, we have Henry Vanderbilt, who's has been pushing at this problem, probably knows a little bit about all aspects of this problem. And then we have Charles Miller again. Holy moly, he wears multiple hats, but then we have the technical side of things. And we have Jess Sponable again. There's a guy carrying two hats again. He may call himself a technologist as well. There's me. I know something about technology. And there's Mike Wright from Ames. He's a very respected aerospace engineer. He's quick to point out that he's more interested in decelerating things, the entry, descent, and landing side of things. But I think he has a great deal of insights in the overall aerospace engineering problem, which includes access to space. So from this panel, I think we actually have a good representation of the demand side, the business side, the technical side, so they can engage the audience in a great deal of discussion, and we'll see where that goes. So I'm going to ask each of the panelists to say a little bit about their view of this problem, introduce themselves, and if you wish to, if you feel you're not going to chew up too much time, for example, whatever you say is that I would put two questions to you, just to prime the pump on discussion. First of all, do you think LCRATS is possible? Should be an easy thing to answer, but I'd like to hear it. And if so, what are the challenges from your perspective? What are the challenges from your perspective on this? And then after they introduce themselves, we can open up to questions. Jim? I think that's all.
Okay. Oh, wow. My name is Jim Ball. I'm the Deputy Manager of Center Planning and Development at the Kennedy Space Center in Florida. Also serve as the Spaceport Program Manager for Spaceport Development. Delighted to be here today And I guess by virtue of going first, this gives us the opportunity to talk about LCRATs from the ground up. I do, to answer the question immediately, I believe that LCRATs, low-cost, reliable access to space, is indeed not only possible, but an imperative. And I'll deal with the challenges as I proceed on. Some of you had the opportunity yesterday, I think, to hear our Center Director, Bob Cabana, give you a very high-level introduction of what's going on at Kennedy Space Center, and it's probably no surprise to anyone that we are indeed going through a transformational change. Not a surprise to us that we were going to go through this. We've been anticipating the retirement of the space shuttle system for some time now, and so we've been very proactive in our efforts to try to guide that transformational change in a way that will truly optimize the capabilities that we have as a launch complex at Kennedy Space Center and repurpose those capabilities to the greatest extent that we can to support this new government-industry relationship that's emerging. And so if you ask what is the future of KSC, I would tell you today with complete confidence that our future defining characteristic is that we will be a multi-user space launch complex serving both government and commercial providers of launch services and their customers. I will also tell you it's a whole lot easier to say that than to make that transition. However, we have been working with industry and other government agencies, very engaged with them over the last couple of years to get their input, get their ideas about how would you like to see KSC change? What are the kinds of things we need to do? What is the infrastructure that you need? What are the services and capabilities that we need to have here to support your activity? And of course, we've gotten great input and have some great relationships forged with many of the companies that have been represented here at the conference and spoken. What we are trying to craft now is a future development concept for KSC that gets us to that vision. And indeed, we're updating a master plan for our 140,000 acres. And so I again take this opportunity to invite informally all of you in the room, all of you in industry, as a stakeholder of that national asset to give us your ideas over the next day or so, or over the next couple of weeks, or as you want to provide them to us, as to how we can make that transformation be of greatest value to this enterprise of expanding our movement out into, of civilization out into space. I listened to Jim Muncie's comments at lunch, and indeed, I do think what we're doing is relevant to space settlement. There isn't anything that goes into space that doesn't start from the ground. And indeed, I think most settlers will at one time have an interest in returning to their home planet. And so think of us not only as a launch complex, but as a recovery site as well. We just demonstrated that with the Space Shuttle system about a week ago. We look forward to having a diverse portfolio. We understand when the discussion comes to LCRATs, low-cost, reliable access to space, we are keenly aware at KSC that that begins with an affordable, adaptable, scalable launch complex, reliably accessible, dependably accessible, and providing the kind of infrastructure and services that can be bought by the yard for a system, for a wide range of systems. So we're trying to design such a place. And the real value of doing so, also with regards to LCRATs, is it leverages an enormous amount of public investment that's been made in the Kennedy Space Center over the last 4 decades. There's absolutely no reason why we should diminish that capability. It's some of the best geography on the planet for getting off of it, and the only place where we've gone to another celestial body, the moon. And so we see it not so much as trying to sustain what we have had in the past in terms of the buildings and the improvements and such. Where those are applicable to the future, let's use them. Where they're not, let's replace them. But from a standpoint of a national asset capability, if you want to save money on getting into space, start by saying, how can we use what we've already invested in and not try to recreate that capability somewhere else? So the challenges are in the details, how to get there.
So I'm Al Tadros from Space Systems Loral, and thanks to Clayton Mowry, who spoke a little earlier from Ariane Space, my charts are reduced from about 80 or 90 to down to 10, so you can thank him later. I have a set of charts. I'll go through them fairly quickly, however, so don't blink, that talks about LCRATs from the reference point of the communication satellite industry. And again, Clayton very eloquently described the financial reasons why the SATCOM industry has been so successful and sustainable in funding not only the satellite manufacturing and deployment, but also the launch vehicles that deploy these satellites to the geostationary orbit. Space Systems Loral, which is right down the road from here in Palo Alto, has 21 satellites currently under contract for customers all over the world. This is an international market that deploys satellites and operates them. Those 21 satellites will all be launched in the next 3 years. So we have a launch pace of about 6 or 7 a year that has been persistent over the last 7 years or so now. That launch pace has developed a relationship with a series of launch vehicles that I'll talk about later that depends on us and we on them, and that kind of industry dependence has been able to not only assure us access to space, but also affordable access to space. How we do that is by providing the same capabilities, the same core manufacturing and infrastructure to a number of mission areas, whether it's commercial or civil services or military systems using the same space segments, technologies and infrastructure, whether it's commercial fixed satellite services, which are the traditional old style, let me say, geosatellites, more recent direct broadcast satellite services like DirecTV and EchoStar, mobile satellite services like TerreStar and ICO, or broadband access, a lot of KA services now that are deployed in geostationary orbit. Those are all built off of the same infrastructure, leveraging the same technologies, and but different markets, different revenue streams that feed into, again, the launch vehicles, paying for the launch vehicles and those services. Those same capabilities, I didn't touch it, those same capabilities also allow us the option for hosting payloads, and Clayton mentioned that as well. The idea of getting access to space, low cost, reliable as the other GeoComSat services that we put up, getting the same level of reliability at lower cost exists by hosting payloads on geostationary orbit. And there's a long list of successful demonstrations. Let me say the majority of them, the vast majority of them, have been international. The international community regularly uses commercial platforms to deploy systems, I believe largely because they don't have their own launch vehicles for the most part, and they don't have the budgets to deploy free flyers for all the programs and all the missions that they're looking at. Interestingly enough, the ComSat industry, which is, again, sustained by commercial revenues and industry revenues feeding into these services, has spun off technologies that serve NASA. not NASA and government-funded technologies serving us. And I'll just mention here 4 of them that we have had the fortune of providing. Antennas, KA high-gain antennas that we deployed for the Solar Dynamic Observatory at NASA Goddard was built here at Space Systems Loral based on antenna technologies that we have. There's Grace and Grail program that where we built KA crosslinks, again based on our KA payloads. Nickel hydrogen batteries for the space station were built at Space Systems Loral based on the nickel hydrogen batteries that we had developed for the SATCOM industry. And most recently here, we're building the propulsion system for a lunar orbiter that is based directly on the propulsion system for our geocomsats. Again, a way to leverage the existing industry to provide more affordable capabilities for other missions. I mentioned the launch pace industry-wide. It's, as again, Clayton covered and allowed me to cut out lots of charts. About 22 launches or geosatellites launched each year. These are the current systems that we have used and the number of launches. And what you'll notice is that the vast majority are on Ariane 5s and Protons. Those are the workhorses for the commercial GeoSatcom industry. We have used Sea Launch, and when they return to service here, they will be in part of our manifest. We have used H-2A from Japan, and the Falcon 9, as it's being developed, will also be in the manifest as well for the commercial geo launch industry. And to make the point more emphatically, what the GeoSatcom industry can do for launch services, this is our manifest for the 21 upcoming launches that I mentioned at the beginning of my talk. A lot of the satellite owner-operators will contract for launch services well after they've contracted for the satellite to be constructed. So we have to stay compatible across all launch vehicles. So that's why there's TBDs in many of these. However, what you'll see is continuing out for the next 3 years, it's primarily Ariane and Proton going forward. Is there a reason why it can't be a U.S. commercial launch service? No. The main things are price and accessibility. Those are the 2 things that drive our industry. And with that, I'll close. Thank you.
So I'll go next here. Charles Miller, I'm a Senior Advisor for Commercial Space at NASA headquarters. And one of the things I do is lead the agency's thinking about emerging commercial space activities. Beyond our existing commitments for like commercial crew, cruiser, COTS, those types of activities, I lead the agency's activities thinking about what's next. And a year ago, we started a process, a little over a year ago, we started a process designed to lead to an answer to that question. And NASA leadership asked me, they said, you know, what's the top 2 or 3 priorities of all the things? So, and this is what Bobby wanted me to focus on last year. And we brought in all the mission directorates, we brought in all the NASA centers, we made it very inclusive. And at the end of the process, and we identified originally 13 different capabilities. We, after some work, we decided it was better to classify them as 8 different capabilities. Almost unanimously, but it was unequivocal that low-cost, reliable access to space was the #1 priority as the next emerging priority that we should be focused on. And just to let you know what our definition was of low-cost, reliable is we meant an order of magnitude lower cost than current capabilities and an order of magnitude better reliability. And that's everybody agreed on. Now I agree with Preston. The biggest barrier to taking this on is there's very smart people who've blunted their spear on this over their career, some of them in the shuttle program, some of them senior leaders in the agency who want this. Everybody wants the conversation in NASA. Everybody wants low-cost, reliable access to space. It's like they're skeptical, and they need to show me what you're talking about doing new. So The good message here is there is agreement that it would be great if we have this. The issue is the debate of how. What Preston is very important in is he's got some new ideas. We have some new ideas in the emerging commercial space activity of how to answer the how in this industry. Many of you represented here have some ideas of the how. So it's not the should we. And in answer to Preston's question about whether it's impossible, is I note that this leader didn't put it in a public statement in writing, probably for fear that he would be remembered like Lord Kelvin in 1895 said heavier than air, flying machines were impossible. So I think anybody saying that is asking to be remembered in history for that statement. And all the great things Lord Kelvin did, other than he's got his name on one of the temperatures measurements, is that quote. I think the clear answer is yes, we're going to have low-cost, reliable access to space. The question is not if, it's when, and maybe more importantly, who. The rest of the world, is not going to sit here and wait for the United States to invent it and just copy us. Okay? Some of these other countries could be the countries that have this. So there is a strategic part of this, just like there was a strategic aspect to the invention of flight. And that's why the DoD has put a lot of money over many decades into it, and why they're continuing to focus on it. Just Sponable here from the Air Force Research Lab. There is clearly a very strategic aspect. There's many markets that would be opened up and capabilities. And so, it's fallen off, but one of the things I'll just note, in the last 5 or 10 years, it's kind of fallen off the conversation of the national conversation. In the 90s, it was a huge conversation about it, but we've gotten distracted by other things, other important things. There's a national debate going on, appropriate role of government and private industry right now, and it's a debate that needs to be having. But at least it's hard to introduce a new subject. But what I invite this community to do is this conversation is going to come back and emerge again, and you can start it. You can start that conversation and help form it and get it going. I'll add one other thing that was a real shock to me last year. The next question that Bobby Braun asked me to ask the NASA team to answer was, okay, that is the #1 priority, low-cost, reliable access to space. Do you have any further thoughts on strategy, and what are the barriers? What are the key barriers that are getting in the way? So this is led by the Office of the Chief Technologist. Out of this process and discussions that emerged, and I was surprised there wasn't much debate, is that everybody agreed that low-cost, reliable access to space, the #1 barrier was markets. That it was possible to achieve much lower cost, much more reliable access if the market demand was high enough. If you had the demand for 30, 50, 75 flights per year, you could close a business case. It was mostly existing or near existing technologies. And that was tied to, you couldn't close the business case because you couldn't prove enough flights to investors. And so it's a tied in. So the #2, because it's related to the first one, is the cost of capital and the access and risk of capital, the risk averseness of capital that much. So the combined set of business risks prevents significant private capital going after that. If you look at some of the business models, they get billions of dollars to go after businesses. Look at digital radio and digital television. They raise billions of dollars in capital. You look at some of the other ventures going on, there's billions of dollars of capital that can be raised to go after attractive business cases. And the truth is because you cannot show the applications and say, yes, you guarantee the market's there, it's proven. So that is really the biggest barrier in the way. And then everybody also agreed that technology is also an important aspect, because as you add technology, you can add more margins in, and you can have more reliability, and there's various ways to get the price down. So it's not like an either or. But I think there was agreement out of this assessment process within NASA that the number one barrier was markets, and tied to that investment capital. You may hear a little bit from Hoyt Davidson, who supported this analysis from us. Hoyt, when are you talking? It's next. You're talking next. And so I just want to leave you that. And then further, we started looking at, well, what are some near-term markets? If the number one priority is flight rate and markets to justify the closing the business case, we identified at least one possibility that appears very attractive, that could go a long way to closing the business case, and that's propellant depots. And if we had a propellant depot architecture, our analysis suggests that it might close the business case for justifying investments in reusable launch vehicles. And if you think about it, we've agreed that NASA should be having humans explore beyond Earth orbit, sending humans at flexible path, whatever you want to call it, going to the asteroids, to Moon, to Mars, all of the above. The key here is, if you have using chemical propulsion, you need about 250 metric tons a year for a robust exploration strategy, or 500,000 pounds a year. Well, that's 50 flights of 10,000 pounds a year just for propellant. And when you add up all the other markets that for a rocket, you actually, an RLV or some other system could capture a large portion of that and close their business case. So that's a very attractive proposition. There are ways to get at this. And there's also lots of opportunities in technology in the Office of Chief Technologist to further advance, reduce the risk, advance the case, and of different concepts based on a pure NACA model. Some of you may have heard my discussion of the NACA approach. This would be perfectly consistent with an NACA approach to advanced technologies broadly shared with U.S. industry to bring about the day that we have low-cost access to space. So I'll stop there.
So my name is Michael Wright, and I'm here at Ames. As Preston introduced me, my focus is more on coming home from space, not getting there, but if we are talking about humans, both parts are important, and a lot of the technology challenges are similar. What I've been doing for the past couple of years is technology development for entry, descent, and landing, both in exploration as the PI of an EDL project, and also in aeronautics as the project scientist for EDL technologies in hypersonics. And we've looked at a lot of evolutionary and revolutionary technologies, and not too surprisingly, our conclusion is you can pick at the edges with evolutionary technology development. You can lower mass of systems, thermal protection systems. Factors of 2, I think reduction in cost are possible with evolutionary technologies. To truly reduce order of magnitude, it needs to be revolutionary. And we're looking at some of those from the entry standpoint as well. In fact, some of those technologies are being picked up in Game Changing next year, looking at decelerator systems that inflate or deploy, change shape prior to or during entry that may truly change the game of how we do this. Do I believe LCRATS is possible? I do. What is the challenge in my mind, if I put my technologist hat on, the challenge is those words: low cost, reliable. Those two phrases don't go well together in my mind. Reliability implies testing, gathering statistics on how systems fail, why they fail. Testing is very expensive and very hard to do for both launch and entry systems, and in fact, frequently impossible to do correctly on the ground. It requires flight testing, and that's something that we haven't been able to afford much of as an agency. To truly establish reliability, you're not talking about one flight test, you're talking about many. How do we get around that? Well, I can see a couple of possible ways. One is increased reliance on analytical capability. High fidelity simulation can replace some, certainly not all, but some of the testing requirements in order to establish reliability, but only if it's truly high fidelity capability, because we're extrapolating ground test results to a new environment via analysis tools. And if I'm going to extrapolate with analysis, I'd like to have some confidence that the physics are being modeled correctly while I do so. The other thing you can do is, back to your comments, we need the market. I think we probably realistically not only need the market, but we need the market with some risk tolerance and some staying power, because we're probably going to be establishing reliability of these systems by flying them with payloads and having some of them fail. And we need to be able to overcome that and move forward and learn what we learn and continue to improve it if we're actually really going to get there. But I think we can do it. And that's really all I have.
My name is Henry Vanderbilt. I run an outfit called Space Access Society. We're an educational and advocacy group. We're dedicated to the sole purpose of promoting radically cheaper space transportation, radically cheaper access to space. In answer to Preston Carter's question, yes, we think it's possible. In answer to the second part of the question, we think the technological aspect is not easy. It's been getting easier with every decade that passes as the technology base builds up, but it's still not easy. It's going to take some very good engineering, some very good organization to come about. And we're really glad to see a lot of that in the works these days in a variety of places. The larger problem's been mentioned by a number of people, developing the market to the point where it'll support the development of the systems that will do that. It's not there yet on a fairly commercial basis. The government help is needed to push things along past that point. And that brings me to what I think at the moment is the most difficult aspect of the problem. And it's the intersection of politics and organizational cultures that we've been talking about, some aspects of a good deal at this conference. If you look at it very broadly, there are two major types of organizations that take on fairly significant aerospace projects out there. There's a classical type of organization. It tends to be located more or less in one place, fairly closely integrated, a single unified team, often led by a single strong figure with a good combination of charisma and engineering talent. Werner von Braun's rocket team stashed away down in a little town called Huntsville is a classic example. There's another type of organization that takes on major projects. It's considerably more parallel. It tends to be very geographically spread out. It tends to be run a lot less by improvisation and informal communication, and a lot more by formal procedures. It's basically a military governmental type of organization. It's, for instance, what the military uses to plan a large invasion. It tends to be very redundant. It's spread out. There's a lot of overlap in capabilities. There's a lot of backup capabilities. If some particular sector of it gets wiped out, somebody else is there to step in. It's very good for getting things done that absolutely, positively have to be done. It tends to cost more, and some combination of costing more and taking longer, however. Through a bit of an historical accident, the major U.S. civilian space agency is the second type of organization. I mentioned Werner von Braun and his crew. When they were merged with the NACA, the NACA didn't have that many locations, tended to be small local teams. They were possibly a little more bureaucratic and spread out and laterally organized in von Braun's rocket team, but not that much so. The historical accident was the advent of the Apollo program and the political call to achieve a specific goal of going to the moon, bringing a man to the moon and bringing him back before the decade is out. The urgency of that caused a military style of parallel organization to be adopted. The resources were no object. Time could not be wasted. Risks needed to be minimized. A massively parallel approach was what was needed. That was the way NASA was put together in the early 60s during the Great Expansion. It's the way it achieved Apollo. And it's basically the way the organization learned to do things and has continued to do them that way since. It worked, why fix it? The problem with that is that the resources weren't necessarily there afterwards. One of the things that happened in the earlier 70s is NASA's budgets got scaled back to perhaps a third of Apollo peaks, and for various reasons their staff stayed at about 2/3 of Apollo peaks. A lot of the results were interesting, to say the least, but that's a bit of a digression. The fact is NASA is still an organization that is designed to minimize risks and maximize the probability of a specific result at these days considerably increased resource costs to achieve the goal and considerably increased time costs to reach the goal. If the goal is commercially viable, low-cost space transportation, there may be a problem there, because if you're putting that much investment into it, it's not necessarily going to end up low cost. If you're doing it with an organization that's not necessarily oriented towards creating low cost, it's not necessarily going to be low cost. You need to get back to the older, more entrepreneurial, more centrally located and tightly integrated sort of organization, which these days is largely the commercial outfit. The commercial outfits tend more towards that. It's not universally so. A lot of them have large government contracting arms that are used to dealing with the government way of doing business and adapted to that. Some of them have more or less coexisting with those more centrally, more tightly integrated, faster moving entrepreneurial commercial divisions. Some of the outfits out there that are working on producing low-cost space transportation are purely commercial, entrepreneurial, tightly integrated engineering organizations. The organizational cultural problem I alluded to is the interaction between the government with a very widespread parallel organization and that way of doing business and these entrepreneurial organizations. We've discussed the symptoms of it a good bit over the last couple of days. Things like whether it should be cost plus, whether the contracting should be under the FARs. Those are symptoms of the problem and shouldn't be focused on overly much. The real question, if you really want low-cost access to space on a tight schedule, on a tight budget, you need to adapt to the entrepreneurial way of doing things. On the other hand, as we've seen, the market isn't quite there yet, and you're going to need government participation. There's going to be a tension between the two. Working out that tension is going to be an ongoing political process. Some of you may have noticed we're involved. Many others are involved in that process. With luck, the end result will be an accommodation that will allow the country to end up with a commercially viable space transportation industry. One quick plug for the organization. We put on a conference every year. It's very much aimed at the startup end of the commercial industry. From the amateur through the startup, and it's been described as the hackers of space transportation conferences. It's called Space Access. It's in Phoenix. It's in April. We don't have our date set. Keep an eye on our website, www.spaceaccess.org, space-access.org, and should have word out there in the coming months when the conference is going to be. And with that, I'll pass things along to Jess Bonneville.
Thank you, Henry. Is this working? I'm with the Air Force Research Laboratory for the last quarter century. I have been almost exclusively chasing low-cost access to space, reliable access to space, LCRAS. Primarily from a government perspective, but also a few years in the entrepreneurial sector. There's three basic ways in my head that you can do this. One is with a low-cost expendable. Elon is probably the best that's ever come in that area with his SpaceX Falcon system. But Falcon 9 is still $60 million a launch or thereabouts. I can't go take a ride next week. There's also some new physics guys out there pushing really crazy things. Some of them have real test data. Whether it means anything or not, don't know yet. but watch that sector. Never can tell when the physics of the world is going to radically change. And then what I've been pushing, advocating, chasing, is a reusable systems, either hypersonic air breathing or rocket powered. Hypersonic air breathing, tough to do at this point. The technology just isn't quite there, although there's possibilities coming. Rocket powered, that's kind of interesting. It's probably doable. You got two variants, single stage orbit, two stage orbit, or even more than that, three stage orbit. I believe LCRATS is possible. I believe you can do it with a rocket-powered system. So let's put some metrics on it. Just looking at all the studies we've done within the Department of Defense in that quarter century's time, I think you can get to $300 a pound. I think you can get there fairly readily. It's a tough technology challenge. It'll take longer and cost more than anyone thinks. Reliability, I would agree absolutely with Charles' metric of order of magnitude improvement in reliability, which to me means at least 3 nines. So how do you do it? Well, let's skip the technologies. There's a lot of ways to skin this cat. But it's pretty easy, really. It's called experimental aircraft. We've got a long history of building and flight testing experimental aircraft. You want reliability, you don't fly it once. You fly it 10 times, 100 times. Going back to the X-15, 199 times. Make it fully reusable. You got expendable components going to come off, you can't afford to flight test it. Make sure the propellants aren't too expensive. You know, you design it from the get-go for reliable, operable, safe operation. And then you go out and fly it. I don't need to put a person on it initially. The modern autonomous operations and electronics, computer software has evolved to such a phenomenal extent, even in the last 20, 30 years, that you can fly this thing unmanned, you can not take risks with people, and you can build up the reliability over time. I remember a story once that when the 747 first flew, it had a reliability of 96%. Probably about right for the first flight. But by the time they get through with an entire flight test program and all of the component testing and everything else, that reliability is going to be up in the many, many nines. So you take this approach where you do an experimental vehicle and you build it and fly it. Now when I say experimental aircraft, it doesn't necessarily have to have wings. Vertical takeoff and landing works. Horizontal takeoff and landing works. Vertical takeoff, horizontal landing works. What you need is reliability, operability, maintainability, supportability. It's got to be a maintainable, operable system. So that, in my head, is the way we get there. And that is a fundamental role of government, is to develop and flight test the kind of technologies which the commercial sector will use in the future to radically lower the cost of access to space. The second order of magnitude beyond the $300 a pound. So let me tell you a little bit about what the Air Force is doing. We are not trying to take that step, but we are trying to build an experimental flight vehicle and flight test it. And we're basically trying to demonstrate the technology for a reusable first stage. In NASA parlance, a liquid flyback booster. Would be liquid propellant, LOX hydrocarbon, LOX RP. We would take off vertically, land horizontally, and we would demonstrate the potential to use the rocket engine itself to return to the launch site and therefore recover at the launch site. And that's the technology base that we're pushing, along with a number of things like integrated vehicle health management, adaptive guidance and control, very lightweight all composite structures that are integral load bearing with common bulkheads, things like that, linerless, fully LOX compatible. We'll be testing a tank that's 7 foot in diameter by about 19 foot long with the common bulkhead, all linerless, all composite, Lockheed Martin machined in the 2012-13 time frame. We're going to put it through 100 mission cycles up as if it were going up and down with cryogens on the inside and heat lamps on the outside. So we are pushing the technology to the best of our ability forward, and we hope that we will be able to work with the commercial sector in the future as we figure out how to operationalize this technology. We're certainly developing it also for the potential for Air Force applications. And we are eager to have NASA join us. We really don't want to go do a hypersonic flight demonstrator, which is what we're getting ready to award a contract for in the next month or so, without NASA on board with us. So yes, L-Crouch is possible, and yes, the technology can be developed to make it happen.
So before I let my panelists talk, I cleverly avoided answering my own questions. I agree with my panelists. I think low-cost access to space is doable. I think it can be achieved. And I think the challenges are really we have to look more balanced at the entire problem. The entire problem being the market, the business, and the technical. And when we look more balanced at it, that I think we will find that solution. How game-changing is going to be, game-changing technology division, my division, how we are going to be approaching that. I'm definitely going to be looking for projects to do. By the way, I want you to come and tell me what projects I should do. You know, I can listen, and you know, I think I need that input, but I can tell you I'm looking for projects to do that will increase application. You know, that there are more applications that'll help on the demand side. And then also I'm going to be looking, we've actually done some studies on low-cost access to space, and we know where the important parameters are. You know, where the important factors need to be worked on. And it was surprising to us. You know, some of these factors are not often discussed in the technical world. I can tell you the priority. I don't want, we can go into detail afterwards, but reusability is, as long as the reusability is above 50%, is very important. Low-cost manufacturing, this is actually an order of priority that we've been finding. Low-cost manufacturing has been important. Sunk cost, that is using technology where it's already been designed. There's probably existing product you can buy, existing engines, things like that. So relying on sunk costs, relying on modularity in the system. Lightweightness. Notice that lightweightness is number 5 on the hit parade. Most engineers would say light, it's got to be light, it's got to be light. They're right. However, it should be modular. It should have sunk costs, probably in priority to the modularity. Leveraged components, so if you can have components you have to pay for, like existing motors. It doesn't happen very often, but you know, but you can. That can really help a great deal. The cost of the ground facility and maintenance. That's kind of the pecking order of what will impact the problem as we've been seeing it. So let's open it up to the floor. I think it's, let's get some discussion. Sir.
We need microphones. Can we borrow one from up there? Yes. Okay. Go ahead.
Current launch rate's about 100 a year, maybe a little bit less. And if you really wanted to have, you know, we really like to have 1,000, 10,000 a year. Then you can really get the price down. There's only 2 applications I can think of: tourism, space, solar power. Am I missing something? There's another one somewhere with that kind of flight rate.
I can name a couple. You guys go first.
I can't think of any that have that high a flight rate other than perhaps if there's some game-changing breakthrough in space manufacturing that's something that makes a huge difference here on the ground that you only can manufacture in space. So, but that's kind of receded to as a possibility compared to the other 2.
I tend not to worry too much about one single application that'll produce the flight rates. As capabilities come along, as we've already seen with the suborbital science, you know, people will start emerging from the woodwork to use them, and they'll surprise you.
With 6 billion people on the planet, that's a lot of pounds of payload. I think all you need is tourism. The real issue is, can you make it reliable enough, and you can make it low cost enough? And even at $300 a pound, there's enough people with real money in the world to make it a thriving business. So, yeah, I would agree. Don't worry about the particular mission too much. The government's going to be in the middle of it because there's too many national security implications for us not to be. There's too many national security implications for us not to be at the front end of it. It is not something that we can cede to the rest of the world without becoming a secondary power.
I will add that there is another market that some people talk about, and Richard Branson is interested. Is point to point. So he thinks that's a potentially big market, and he's got a business there. He runs Virgin Airlines and a variety of other airlines. So he's personally and some other people are looking at that application.
And there's probably one other that we ought to not forget. Certainly is shown to be of importance to some of the suborbital systems, especially the guys that are getting into the vertical takeoff, vertical landing, and that's STEM. And the idea of providing, low-cost flight opportunities for experiments that, granted, don't get you into orbit, but get you into space. And the development of those systems and the technology, it all moves the ball down the field.
I would add that, it's really the market for any particular launch vehicle is more like 10-ish, not 100. That'd be great. And actually moving it to about 100 for a launch vehicle would be tremendous help to close the business model. But also I'd say, you also want diversity of market, diversity of type of customers. But then, if you want to get to the hundreds to perhaps the thousands, like you're speaking of, I mean, many of the markets there's fuel depoting. If you have tourism, then you also have research. Yeah, because people start doing research more in situ in the space environment. It also depends on the size of the market. Obviously, manned space is the medium launch scale of things. Telecommunications is usually on the larger scale of things. There's also the micro. In the micro, are they launching tens or dozens of microsats at one time, or doing one at a time? So you could actually get quite a few launches that way, and that'd be probably different than what some people are imagining here, but that would actually be a significant market as well. On a very, very large scale, when you start getting to telecommunications robustly, you start including servicing of satellites, then you start getting space station scale objects in GEO. And just the infrastructure that would generate a great deal of market to orbit. So here's a question we got from the web, is that the description of this session describes LCRAS as less than $2,000 a pound to LEO. That's twice what SpaceX is charging for Falcon Heavy. Does anyone have anything to say about that?
Well, yes, from my perspective, low-cost access is an order of magnitude lower than the Falcon 9. It's $200 a pound instead of $2,000 a pound that Elon's charging for his vehicle. So maybe it's just an issue of description on the title, but we're talking about something else. Most of us up here.
And I should add, not that anyone could ever speak for Elon, but Elon himself wants his system to evolve to a fully reusable system and bring the cost down and improve the reliability. And he is constantly pushing his engineers to find ways to make that happen in the future. So it's an interesting future that's rolling at us.
And if I could mention in this regard, there was a fairly well-known market study back in the 90s that estimated that somewhere around $600 a pound cost to orbit, there was an inflection point where the market growth would take off to the point where essentially the overall size of the market would start increasing despite the decreasing cost per pound. These days, $600 then is probably about $1,000 now. But whatever the exact number is, that inflection point is the place we need to get to. I don't worry too much about a specific figure. I worry about driving us past that inflection point.
Within Game Changing, we've done some analysis recently in order to guide our investments into LCRATs. One question I asked is that now that we know where things sit, how far could we push it? How cheap could we get? There's also not just dollars per pound, but also the level of investment required. You want to reduce both of them. You want to make it so the life cycle cost is low. And I was actually surprised by the answer. I think I'm more in agreement with Charles, is that at the scale of market like today, so tens to hundreds size market, not large market, you can get to $200 a pound, $300 a pound, in that range. I think that it actually is possible with the right technologies and the right kind of concepts and systems. If you start getting to the thousands, then getting down to below $100 a pound actually is possible. but that only comes once you have demand that drives it as well. So here's a question again. Well, let me take one from the crowd. Anyone see, sir?
For getting people to orbit, one way to describe the cost is cost per pound times number of pounds per person. Every design that the U.S. has done since Mercury has been heavier than the last one per seat. When are we going to turn that around? The Dragon, the Falcon 9 is 20+ thousand pounds to orbit, and it's taking 7 people, 6 or 7 people. Okay, that's 3,000 pounds a person. John Glenn in his capsule was 2,600 pounds. Okay, why can't we reduce the cost of getting people to orbit by getting more people per pound of capsule?
I can answer the time when we'll do that, Joe, is when you get multiple space lines starting to compete on ticket price and trying to shave weight and pack more seats into their capsules like the airliners are packing us in these days. That's the point where you'll start seeing serious attention paid to that.
And I think what you're seeing is exactly the conflict between low cost and reliability. You're seeing reliability win out, which is driving up mass. And that's hard to fight against without a lot of statistics, a lot of repeats, a lot of testing.
Sir. Okay.
Having looked at some of the factors driving cost up, what I tend to see is a lot of design cycles, a lot of schedule being absorbed in trying to get minimum mass, maximum performance. I'm thinking there may be a trade-off there, that if we could reduce some of this focus on trying to get the minimum mass and maximum performance, we might be able to design faster. We could have higher design margins, so we could be more reliable and require less testing, and therefore get both low cost and reliability, as well as faster. Any comments from the panel?
Yeah, I'll add some. I absolutely agree with you. The fact is that the streamlining of the engineering process, I hesitate, since I'm an engineer, I hesitate to say kill the engineers, but except for this one. And but there's also, as an organization, I don't think we have a mature industry yet. And when you have a mature industry, then people agree to what the margins should be, what the standards should be. I think right now that our industry is primarily dominated by the government and government engineering teams. I think it's probably aggravating that because we'll make it more bureaucratic. We'll change our minds. We'll allow the contracting to dictate things. So that's another dynamic. I think what you're saying though is that for example, as the oil industry, or as the airline industry, or the railroad industry matured, the maturity of the engineering process and the specifications of what things had to be in order to be reliable or durable or have the maximum value, matured as well. And I think we have to recognize our industry is rather growing in Armadillo and Maston and X-Core, have all done a great deal in kind of changing our thinking on the way those things done, where the margins should be, how safe things could be. I think Jess could probably pipe in that the Air Force way of things, they want to be like an aircraft. They want to be reliable, and they want to, they're bringing a level of maturity to the technology, I think, that the commercial sector will benefit from.
And I will pipe in. Yes, you're absolutely right. The systems engineering process should allow for trades of margin and weight for versus reliability and other things like that. However, I would throw up a huge caution. It's really easy to end up with this big, heavy system that has no chance of being economical, because in the end, from a century of knowledge, we pay for hardware by the pound. Every cost model we have is weight-based. So that's a concern. The other thing, if you look at the aviation industry, aircraft, when was the last time we built a heavier aircraft than the generation before? They're always lighter weight, they're always higher performance.
And I think Preston hit the nail on the head by saying we don't really have a mature community yet. We don't have, I spent 3 years working for Orion, leading thermal protection system margin, trying to define a process that was rigorous, that tied to reliability in a quantifiable way. We don't have it. It's not there yet. And it's going to be a long time before it is there.
Yes, sir.
I can try to get it out there, but I noticed in talking to the Mastins, Armadillos, X-Corp, one of the first things they did to address reliability was cut back on performance. And the paradigm being that lower performance actually increases the reliability of the systems you're trying to use. Instead of going to 103, throttle at 103%.
I agree, and also, you know, when one thing that I don't say often, but I'll say in this audience, is that I don't think we have matured as far as the concepts, the system concepts for launch vehicles. You know, yes, the expendable vertical launch is a good approach, but you know, when you start going to lower cost, you'll find that other system approaches come into play that are very attractive and dramatically different. And when you look at trade studies on the sensitivity of those systems, you find that lightweightness, which we were calling reliability in this context, is actually not nearly as a big a player. The lightweightness is supreme for the expendable vertical launch system, but when you start going to other types of systems, you can spend the weight where you need to have the weight to have reliability, and you'll maintain your performance. Sir,
I can actually clarify the startups, you know, the Mastins, the X-Cores, the Armadillos philosophy a little bit from what the gentleman mentioned. Yes, they are starting out by adding a little bit of weight to get more reliability. They're doing it to get reusable systems they can test a lot. Ultimately, they understand they're going to need really high performance, which is going to involve shaving weight. The process is going to be a matter of testing things an awful lot to find out where you can and cannot shave the weight and keep the reliability.
let me, oh, yes, sir.
I'm going to sort of ask a question about the title of your concept, low-cost, reliable access to space. If I can cut the cost by a factor of 10 and make it a quarter as reliable if I'm delivering propellant to a propellant depot, it doesn't matter. There's a 6-year waiting list to climb Mount Everest, and there's a 10% fatality rate for those who attempt it. In years past, it was 20% or greater. Is part of the problem that we have focused too much on we can't ever fail the reliability end and haven't, so.
Since you mentioned depots, let me answer that. We're looking at that. We're doing that exact analysis. The easy way at depots when you're launching, if it's cheap enough, you just add a few more launches in, and you get the system level reliability you need for you have the propellant there you need when you want to do the launch. So we still get the reliability we need for at mission success. That's the propellants there by you build in extra flights as redundancy. So that's how you solve reliability in that case. So from in the individual launch perspective, you don't need it. Okay, so but low cost, it still goes right to the bottom line of the overall cost of human exploration beyond Earth. So you're absolutely right, but it depends on the market. You know, if you're the person sitting on that RLV, you care about how reliable that is. And the perception of safety and reliability, I don't think a lot of people understand this, is we have discussions about this, what is the demand for human space flight at a certain price point as you bring the price down? Well, it's not that simple. It's multivariable. It's like, well, how safe or reliable is it, and how safe or reliable is it perceived to be? What's the destination? How good is the destination? Do you have to train 6 months and go to a foreign country and you learn another language, or can you go to Florida and your family can go to Orlando, and you can train there for a month and just take a month-long vacation and go to space. There's many variables that really impact the market demand of human spaceflight. And one of the big things of Lindbergh, when he flew, he totally altered the perception of a lot of people who had never flown before. There was a huge spike up in regular personal travel on planes in the domestic United States within the next few years, just because the safety didn't change, the perception did. So it depends on the market. So I just say is that we don't want to get too simplistic. So for some things like depots, yeah, we have a different way to get the reliability we need. But for human spaceflight, it's a different challenge. And you would really like to have that at least 3 nines.
Let me get one. I see it. So let's take one from the web, just to give those folks some satisfaction. It's but they're not here, are they? Do they have a vote? No, they don't. So they'll have to buy a ticket and come next time. Sir.
When I was working on Space Station, I caused When I was working on Space Station, I had cause to look into how consumer products achieve reliability, and they do it in at least 3 ways that I don't think I've heard yet. One is they make sure that they understand the failure modes and they design the failure modes out. One of the ways they learn the failure modes is they make sure that they get failed units back. We often can't do that yet, but with reuse, we will get those units back, and then that will accelerate the learning process. The third thing is higher volume accelerates that process still more. And just one comment. I was told by one of the SpaceX guys that the most important immediate reason they want to get a first stage back is exactly so they can study it and see if they can find any nascent failure modes.
Hey, Gary, absolutely all of that and a whole lot more is what is routinely done in the aviation reliability. It is designed in from the get-go. You design out anything that can be a single point failure to the maximum extent possible. Obviously, some things like the wing falls off, there's not a whole lot you can do, but you design it so that does not happen. Nothing's perfect. Flight test the hell out of it, and then sell it to the private sector.
I had one real quick additional comment regarding the reliability question, and that's with respect to not only the considerations of what's flying or who's flying on the vehicle, but to cost associated with the protection of third-party interests, whether that's insurance cost or regulatory costs with the FAA or range cost or any of the whole spectrum of things that are put in place today to help ensure to somebody's satisfaction that there's not undue risk to uninvolved third parties, that the improvement in reliability is going to reduce those costs significantly as well.
So let me, this question from the web, I said, this may be an oversimplification, but it seems like current launch technology is akin to building a commercial plane like the Boeing 737, using it once and destroying it. What is done in the field of truly reusable launch vehicles? And is that likely, and is it likely that it could be cheaper than the current single-use systems?
Well, I think NASA did a survey last year of a lot of providers in the United States, and I think there's generally a consensus that reusable launch vehicles have the potential to be an order of magnitude lower cost, an order of magnitude higher reliability than current best systems. And the thing here is people like Elon Musk make public statements that they're convinced too that the future is reusable, and it's why they're working on it. And there's multiple companies at various levels. It's been mentioned, Escort, Armadillo, Maston. They're all suborbital ROVs. All of those companies have publicly talked about their strategy is a disruptive strategy, is incremental, reusable to lower orbits, and they constantly stretch the envelope to get eventually reusable all the way to orbit. That's their strategy. And it's actually the strategy of Cruiser. The deputy administrator yesterday talked about this and said that one of Cruiser's purposes is that we want to energize and partner with these emerging suborbital ROVs because one day they may evolve into fully reusable all the way to orbit. And it's also the strategy of some companies we're partnering with. Blue Origins, who's publicly disclosed recently that they're looking at a hybrid system as part of their partnership with NASA with a fully reusable first stage. And they also have developed a reusable suborbital system, so they're coming at it from multiple aspects. So I believe there's many companies that here in the United States, and there's some overseas, who are investing in this, and the question is, can you pull it off? So, and who's going to pull it off first is the key question.
I will say that studies we've done is showing that reusability, if you do reusability less than 50%, it's almost a cost. It actually drives the cost up slightly. It's not a win. You have to get more than 50% reusability. And really the gain there is rather minor. It just starts being in a positive direction. When you get to 90% reusability, and this is by weight, it turns out that's where the big benefit starts. And when you get down to nearly complete reusability, down to the 95, 98%, that's where the orders of magnitude cost reductions occur. So this is something I think going aggressively at reusability, I think is highly desirable. And going at it, saying having an inherently expendable vehicle that you slightly reuse, perhaps akin to the shuttle's reusable SRBs, is really not the right approach. The right approach is to commit yourself to discovering ways of doing reusability that will give you high reusability, far higher than 90%.
Got it, sir?
Hello? I wanted to ask a question tacked on his question about risk. As we look in the past, the Wright brothers, of course, were building their own planes, jumping in them. It was very dangerous at the time, and nobody was really regulating their life. They were responsible for that. If you look at people currently who are doing land speed records, they can just jump in a car that they feel comfortable with many times in the Black Rock Desert, go as fast as they can, and they're under their own responsibility. So I'm just asking, as we are going to push into the future and look into space flight, is it going to be NASA who's going to determine the risk that humans are able to take in the designs that we build? Or can people themselves say, I feel comfortable with the 90% reliability, I want to jump on this and go flying?
Very briefly, FAA, Federal Aviation Administration's Office of Advanced Space Transportation, is in charge of regulating U.S. commercial space transportation safety. And they have thus far been doing a very good job of balancing the general public's safety versus the individual entrepreneur's ability to take calculated risks to advance the technology. Stay tuned to that. It's an ongoing balance.
Since you mentioned NASA, NASA's focus is on managing and assessing the risk for NASA-funded carbon-based payloads called astronauts. So NASA doesn't get into assessing risks for the private citizens, so you know.
Here's a slightly different direction on questions. So what are the barriers for major NASA Department of Defense investments in the types of new launch technologies that could provide LCRATs, such as beamed energy propulsion, microthermal launch, laser thermal launch, etc.?
probably got the same answer. You go
Well,
first.
I mean, first of all, you know, one man's Elkratz is another man's insanity. So, and nothing against any of the particular concepts that were mentioned, but you know, the government, as a government employee, you do have a duty and an obligation to protect and spend the taxpayers' money wisely. And so there is an assessment process where we go through and we look at all those kinds of things, and we've been involved in all of them at one time or another. But you know, how much money you're willing to spend, ultimately the bureaucracy in the system puts limits on it. You know, obviously if it's anti-gravity and it works and it's floating in this room, somebody's already doing it. All those concepts that were mentioned are good concepts, interesting concepts. They have niche applications. None of them are going to put people in space.
Another way of looking at it is there's a class of methods of getting into space that are technologically feasible, but not really practical as near-term investments, because it's fairly obvious that the overall investment to get to the point where they're economical is huge. Space elevators, laser launches, possibly gun launches. The ground infrastructure is very large, and you have to have a very high volume market before they make any sense. One way to look at it is if you've got a river that currently people are swimming across, the market probably won't support a suspension bridge. You probably want to look at ferry boats first. You know, the suspension bridge may come later.
I was really struck when I read the Aerospace Corporation's work they did for the Air Force on beyond next generation space transportation technologies, that the front end of that study was all about the market. It really was, what are the demand drivers that could generate enough flight rate activity to justify the investment cost that's going to be required on the technology development of new systems, even the one that Jess was talking about, the reusable booster system. And it, you know, considered the gamut of future technologies, even breakthrough physics that could occur down the road. But as a practical matter, you know, we're living in a world of very constrained, limited budgets for technology investments. You know, Charles may want to speak to the concept of breakthrough technology work that their organization is able to sponsor, but still with a very limited resource.
Well, I'll just say that look at the debate going on by our national leaders right now. The resources are limited, and you know, we're not going to put a lot of money into one solution and ignore all the rest. That's you know, it's taking a portfolio approach. Is the Office of Chief Technologist, where Preston and I work. Our general philosophy is want to take a portfolio approach towards targeting some of these grand challenges, and putting all your money in one, you know, taking one shot and nothing else is the opposite of a portfolio approach. So if you come in with just give me all your money and I have the solution, you should consider that type of assertion to us as actually a negative, because you've just made it really risky. But if you can come in with a more incremental approach that you can advance the state of the art, and if you fail, the whole initiative, the whole LCRATS initiative is not failed. You know, that makes it lower risk for us to put the money on you. We rather, that makes it easier for us to say yes. Now maybe you got the breakthrough and you come in and convince us, but I'm just saying, everything being equal, when you come in and ask for, you know, for me to succeed, I need all your money for low-cost access to space, and you're telling us you're risky. And if you can come in and say, hey, I want this much now, and I will show measurable results and progress, and you can measure me, and you know, and it's a much lower number, and you can show how this leads to a breakthrough. That is an approach that fits within a portfolio strategy, and you will increase, just in general, all things else being equal, you increase your chances.
You know, this is actually a typical example of things I see every day in my office, is that, you know, what I try to tell people is I don't fund concepts. what I try to understand are the problems we're trying to solve, and I find solutions to those problems. So I put a great deal of effort in identifying the problems of highest priority and seeking solutions and technologies that will help us solve those problems. For example, saying that energy beaming is for LCRAS, I think is missing the boat, is that when you do the numbers on beamed energy for launch, it doesn't quite play. And so it's not one of the solutions to this important problem. But you know, I listen to people with concepts as well, because they don't always, you know, I want them to tell me what the problem is they're solving. Often they think, here's my idea. They don't think of it as a problem. And so I listen to them and saying, well, I understand he doesn't understand the problem he's trying to solve, but that doesn't mean their technology is not relevant for some other problem he or she is not aware of. So energy beaming is actually a good example. There are problems out there where energy beaming for space technology could be quite attractive and is doable and can evolve for both national security and space technology needs very rapidly, very near term. It just so happens LCRAS is not one of them. And so I will often recognize when someone has a beamed energy concept that comes to me, I will ask them questions driving them to that problem rather than to LCRAS, which is what they came in with when they came in the door. So let's see, we have 2 more minutes. Should we recap or ask one more question, or let one more question be asked? There you go, sir.
So I'm curious in maybe a contrast between the airline industry and the space industry is that in the airline industry, I don't think there was ever a point in time when flying stuff around was the commercial was the commercial driver. I think the airline industry became a commercial enterprise when people were flown around. So it wasn't really a commercial enterprise when it was just mail, et cetera. And in the space industry, the only commercial enterprise to date has been flying stuff around, not humans. And I'm curious if anybody has a thought on when the commercial enterprise will become a human enterprise rather than flying satellites and other types of cargo into space.
When the vehicles are available.
So 50 years, 10 years?
When they're available.
Well, and it's worthwhile pointing out that it already is, but only in one location, and that's Russia. And they currently have 100% of the market in flying humans to orbit. So yeah, that's not the kind of numbers anybody wants to see. You know, that's all it is 8 over the period of time, or 8 or 9, you know, that it's taken to get them there. But it clearly demonstrates the market is there, and it's going to emerge somewhere, and it has first emerged in a country other than the United States. And so I think, you know, you're right, as the suborbital vehicles come online and hopefully in this partnership between NASA and industry to provide commercially available service for us to use to get our astronauts to the International Space Station, this is going to help prime the pump.
Well, let me answer your question. Is our national space policy is that we are investing in commercial crew for 2 purposes: to energize a new commercial industry that can take private citizens to space, and to serve NASA's needs for crew transportation to the space station and maybe other destinations. Okay, so the industry is telling us when they think they can meet that. So it's you know, some of these companies are here and talking about it yesterday. Some of them think they can do it sooner than others, but none of them are talking 10 or more years. So they're all talking, depending on who you're talking to, 3, 4, 5, 6 years. And there's various, don't hang your hat on any date, because there's lots of uncertainties in that. But that's the time frame that people are talking about, having a U.S. Capability to transport humans and private citizens to space.
You know, I would actually say that I agree. I think the time frame is more like on a 5-year scale, not the 10-year scale. I think I think we actually live in a special time where it's imminent. You know, often you don't see it happening until you look in your mirror and say, hey, it happened. And so I think we're very close to that. And I think a lot of the companies yesterday were speaking about their plans, and I think you should hear them very clearly because I think they're serious. And I think they're capable as well. I think that the job that Jesse has and I have, and Charles as well, is to make sure that we're doing things to be supportive of their efforts and to advance the technology that they can eventually adopt in order to drive the cost even lower, so that most of us in this room can go to orbit rather than some of us.
I'd like to jump in here with a totally unsolicited plug for our moderators' interests. The U.S., for a variety of reasons, has spent a number of decades neglecting advanced space technology investment, generally to pay for immediate operational needs. Jess Bonnable mentioned earlier there's a defense need to keep our space technology in advance of whatever else is out there. There's also a commercial need. It's good for the country. There is a need to put more money into something called the Space Technology Program at NASA. The funding's currently in doubt. Look into it later on. If you agree with me, it may be worth your weighing in on the matter.
Okay, so I think we'll wrap it up. So I think one more question. Go ahead. No, sir. Please let's.
It was a space elevator question. You answered
please.
it.
Did I answer it all right?
You answered it, yes.
Okay. It's just a matter, I can't find the button to push for up, so very good. Okay, so very good. Thank you very much, and I think most of us will be up here during the breaks as well. Demand side of the equation. Many people have opinions on how to up the number of launches by the size of payload, the nature of the payload, let's say fuel depoting and other things. There's many strategies there, and those are definitely on the demand side. There's also the business and technical side of things. Engineers will tend to talk about performance of the vehicles, reusability, lightweightness, modularity, things like that in order to achieve performance. Business guys may look more towards the cost, how to get lower cost and other things in order to make the margins for selling low-cost access space more attractive to investors. There's also partnerships, partnering with different people that can bring different value to the formulation of the solution. And these are all very important aspects of low-cost access to space. So when they asked me to be the moderator for this panel, I looked at our panel, and at first I said, these guys are completely unconnected to each other. I go, man, look at this motley crew. How can these people be a good panel? But there was a lot of wisdom put together in this panel. There's a lot of diversity. For example, representing the market, we have Al Tadris from L'Oreal. He may have some things to say and represent adequately the market. We have Charles Miller, who I think most of you know. He's looked at this and looked at the market side of things for a great deal of time. We have the business and partnership aspects, people who kind of understand how that can play in low-cost access space. So from KSC, we have Jim Ball, who's very active in the ground facilities and how that can play in low-cost access space. We have Jess Bonnable, who is here for AFRL, who's has studied this problem for a great deal of time and knows how business and government can play in achieving this. We also have from Space Access Society, we have Henry Vanderbilt, who's has been pushing at this problem, probably knows a little bit about all aspects of this problem. And then we have Charles Miller again. Holy moly, he wears multiple hats, but then we have the technical side of things. And we have Jess Bonnable again. There's a guy carrying two hats again. He may call himself a technologist as well. There's me. I know something about technology. And there's Mike Wright from Ames. He's a very respected aerospace engineer. He's quick to point out that he's more interested in decelerating. Have we failed? Yeah, I think some would agree that we have failed in some cases. So it's a knotty problem, and it's something that I think we have to keep addressing. In this panel, I think, and questions from the audience will be interesting in this discussion. Let me share my story. There's a young man out there, Simon Sorensen. Simon, are you in the room? No, he's still having a cookie. So he's a young man right out of high school. He's a freshman in engineering going to San Jose University. He's all excited to become an aerospace engineer. And we were talking previously about that. And so, here's a story that's I think, to understand the difficult problem. About 8 years ago, I was in the Pentagon talking to a decision maker. And the topic we're talking about is the technology development related to low-cost access to space. And the position this decision maker had was startling to me and quite different from my view of the world. His opinion was that low-cost access to space was impossible and not achievable, and that we should only be concentrating on exactly the way we're getting to space today. And that was, in his opinion, the end of discussion. Now, I point this out because I doubt very few people in this audience share that opinion. But it's very interesting to understand that there are many people in this equation, and some people have that opinion. Maybe it's because of their frustration in seeing the trying and the failing. Maybe they don't have the convictions that I think we share in this room that this is an achievable thing. But also, they could be right as well. Maybe it is impossible. I don't share that, but we have to understand that there's a lot of people who are in this discussion that not necessarily are enthusiastic. So I wanted to share that. So we have a complex problem in solving and achieving low-cost, reliable access to space. Really, there are in the way I look at things, there are two sides of the problem. There's the demand side. That's the market size, the customers. A lot of the solution for low-cost space could just be economy of scale. We get a lot of launches, the prices automatically come down because of volume, economy of scale, the learning curve, things like that will drive it down. We know that, it's well understood. There's a catch-22 there, is if it's too expensive, we can't get a lot of market, we can't get a lot of customers, so how are we going to get the cost down? So there's a chicken and egg problem there, and but there is definitely a
recently formed Office of the Chief Technologist, and his title has the statement "Game-Changing Technologies." Now, I can't think of anything more appropriate to have in your title when you're at a NewSpace conference. So with that, I'll let Preston talk about himself and everybody on the panel. So, Preston.
Thanks, Gary.
Welcome.
Well, good afternoon. I hope we all have had a cookie and we're ready to talk about low-cost, reliable access to space. So my name is Preston Carter, as he said. I'm actually just joined NASA. I have, when I had hair, I was part of NASA in the early shuttle program. And since then, I've gone off to Livermore Labs within the Department of Energy. I've been a program manager at DARPA. I've started my own business on advanced propulsion and power. And now I've returned to NASA in order to help them form the Game-Changing Technologies division within the Chief Technologist of NASA. So just so you know, is that the idea of Game-Changing Technology division is to have a DARPA-like organization within NASA to try and bring innovation and more agile and adaptive ways of promoting and encouraging and enabling advanced technology and innovations. So that's my job, and then so I'm very interested. My job is mostly listening. My job is to identify problems, often expressed as concepts. Concepts are more solutions. I'm more interested in what the problems we are and whether what are the solutions to those problems once identified. But people express things a lot of different ways, and that's just a part of my job, to identify those problems and seek solutions. Now, today we're talking about low-cost access to space, and I wanted to start with a story. I've delved on this problem off and on for about 30 years, and it's a difficult problem. It's very complex, and everyone has many different views, and that's appropriate because this low-cost access to space is difficult from the demand side, from the business side, from the technical side is very challenging. And our ability to solve that has, do you think we have achieved low-cost access to space today? I would say no. And have we tried to do different ideas to try and achieve low-cost access to space? I think we definitely have tried.
The capabilities that we have as a launch complex at Kennedy Space Center and repurpose those capabilities to the greatest extent that we can to support this new government-industry relationship that's emerging. And so if you ask what is the future of KSC, I would tell you today with complete confidence that our future defining characteristic is that we will be a multi-user space launch complex serving both government and commercial providers of launch services and their customers. I will also tell you it's a whole lot easier to say that than to make that transition. However, we have been working with industry and other government agencies, very engaged with them over the last couple of years to get their input, get their ideas about how would you like to see KSC change? What are the kinds of things we need to do? What is the infrastructure that you need? What are the services and capabilities that we need to have here to support your activity? And of course, we've gotten great input and have some great relationships forged with many of the companies that have been represented here at the conference and spoken. What we are trying to craft now is a future development concept for KSC that gets us to that vision. And indeed, we're updating a master plan for our 140,000 acres. And so I again take this opportunity to invite informally all of you in the room, all of you in industry, as a stakeholder of that national asset to give us your ideas over the next day or so, or over the next couple of weeks, or as you want to provide them to us, as to how we can make that transformation be of greatest value to this enterprise of expanding our movement out into, of civilization out into space. I listened to Jim Muncie's comments at lunch, and indeed, I do think what we're doing is relevant to space settlement. There isn't anything that goes into space that doesn't start from the ground. And indeed, I think most settlers will at one time have an interest in returning to their home planet. And so think of us not only as a launch complex, but as a recovery site as well. We just demonstrated that with the space.
Things, the entry, descent, and landing side of things. But I think he has a great deal of insights in the overall aerospace engineering problem, which includes access to space. So from this panel, I think we actually have a good representation of the demand side, the business side, the technical side, so they can engage the audience in a great deal of discussion, and we'll see where that goes. So I'm going to ask each of the panelists to say a little bit about their view of this problem, and introduce themselves, and if you wish to, if you feel you're not going to chew up too much time, for example, whatever you say is that I would put two questions to you, just to prime the pump on discussion. First of all, do you think LCRATS is possible? Should be an easy thing to answer, but I'd like to hear it. And if so, what are the challenges from your perspective? What are the challenges from your perspective on this? And then after they introduce themselves, we can open up the questions. Jim? I think that's all.
Okay. Oh, wow. My name is Jim Ball. I'm the Deputy Manager of Center Planning and Development at the Kennedy Space Center in Florida. Also serve as the Spaceport Program Manager for Spaceport Development. Delighted to be here today. And I guess by virtue of going first, this gives us the opportunity to talk about LCRATS from the ground up. I do, to answer the question immediately, I believe that LCRAT's low-cost, reliable access to space is indeed not only possible, but an imperative, and I'll deal with the challenges as I proceed on. Some of you had the opportunity yesterday, I think, to hear our Center Director, Bob Cabana, give you a very high-level introduction of what's going on at Kennedy Space Center, and it's probably no surprise to anyone that we are indeed going through a transformational change. Not a surprise to us that we were going to go through this. We've been anticipating the retirement of the space shuttle system for some time now, and so we've been very proactive in our efforts to try to guide that transformational change in a way that will truly optimize